Alright, so what we're asked to do in this problem is, given this polynomial function f of x right here, we want to find all of its roots. That is, we want to find all of the x values that are going to make f of x equal to 0. Now, granted, we're already given one of them. That's some information that we are given right up front. The fact that x equals 4 is a root of this polynomial function. And I leave it to you to confirm if we were to insert or substitute a 4 for each of these x variables. Indeed, when we evaluated this whole expression, f of x would indeed be 0. But what does that mean? We already know, for instance, that on the graph of f of x, we're going to have an x-intercept right here at the point 4, 0. But what else does it tell us? It tells us that if we were to factor this guy, I don't know how it factors right now, but if we were to factor him, we know that we'd have f of x equals, well, x minus 4 times something. Now, I don't know what that something is right now. How do I know that x minus 4 is going to be a factor? Well, we've been told that x equals 4 is a root, which means if we substitute 4 in for x, well, we're going to get 4 minus 4 times something. Well, this is already 0, so no matter what this thing is, we're going to get a 0. That indeed is a root of our polynomial. But here's the deal. How do we find this something and that something? Well, we're going to have to do some polynomial long division. We're going to have to divide this big polynomial by x minus 4, and we'll get some summary statement, which will tell us exactly how to rewrite that equation right there. So I'm going to go ahead and set up some polynomial long division. I got my long division hut here, if you will. We got an x cubed minus 7x squared plus 2x plus 40. I got to divide all this by x minus 4. So what I do first is say, well, what do I need to multiply x by to get x cubed? And I say, well, that's going to be an x squared in this case. So I know that this guy right here is going to have an x squared in it. All right. Well, now how much do I have left over? When I multiply x squared by this entire divisor, well, we're going to get an x cubed minus 4x squared. Now I'm going to subtract this whole quantity from our big dividend. And we end up with, well, let's see, well, these two add to 0. That's great. And we're going to get a negative 3x squared here. I'm going to go ahead and bring on down this 2x. Now I ask myself, what must I multiply x by to get negative 3x squared? I think I need to multiply it by negative 3x. So boom, right away we know that we've got a negative 3x as part of this remaining factorization here. Alright, cool. Alright, so now I say, well, what do I have left over? I'm going to multiply negative 3x by our entire divisor, and we end up with negative 3x squared plus 12x. And of course I'm going to subtract this whole quantity. And what do we have left over? We're going to have a 0 here. That's great. That's exactly what we want. We're going to have a minus 10x. And then bring this guy over plus 40. And then I ask myself, what must I multiply x by to get negative 10x? Well, I think I got to multiply it by negative 10. And so minus 10. And we've actually already found, well, let's confirm. We believe that this remaining polynomial in here is going to be just that. And I multiply my negative 10 by our entire divisor over here, and we get a negative 10x plus 40. And when we subtract, we indeed get a remainder of 0, which is fantastic. Now remember, when we actually used to write these polynomial summary statements, we would write something along the lines of, I'll do it down here, we'd write x cubed minus 7x squared plus 2x plus 40, and we'd write it using our divisor and our quotient. We'd write that as x minus 4 times the quantity of x squared minus 3x minus 10. And note that, I guess you could almost say our remainder is 0, although there's no need to write that. And thank God the remainder is 0. If there wasn't a remainder, like imagine there was a remainder of 2 or something, 4 would no longer be a root of our polynomial, right? Because although this would be 0 and this product would be 0, We wouldn't get a 0 overall. So it's a really good thing that we ended up with a remainder of 0 and not something else. So check it out. But this polynomial right here, this is our function of x right here. So we can use this information right here to go ahead and scroll up and rewrite what we already did. We wrote our polynomial function here as such. Let's see if I can get rid of that little box. Awesome, 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 awesome. And so there is our polynomial function. We rewrote it as x minus 4 times the quantity of x squared minus 3x minus 10. And here's the great part. This guy in here, oh yeah, it factors x minus 5, x plus 2. And so I claim that we can write our polynomial function f of x in a fully factored form as f of x equals x minus 4, x minus 5, and x plus 2. Meaning that the roots of this polynomial function, the x values that will make this guy equal to 0, will be positive 4, like we were told, positive 5, and negative 2. And so I claim that we should have x-intercepts at all three of these points. So we already have one at 4, we should have another one at 5, and we should have another one at negative 2. Now, do I know exactly what this polynomial looks like? No, not off the top of my head, but I do have a picture of it. Let's see if I can find this guy. Oh, I forgot to add it to my camera roll. Alright, there it is. So if you plug this polynomial function into your graphing calculator, you will find this graph right here, which confirms our 3 x-intercepts at the coordinates positive 4, at the coordinates positive 4, and positive 5, and negative 2. And what I also did is I also did one with my computer graphing calculator right here, and here's a kind of zoomed out view, so you can even see that y-intercept way up here at positive 40. But note to self, it also has those exact same x-intercepts, positive 4, positive 5, and negative 2, like we suspected.